And we're live, hopefully. Wonderful. I'm looking forward to this one today. So, hello everyone and welcome back. So, the plan for today was not this originally. In fact, there was supposed to be a printer coming for this week, but it hasn't arrived. So I thought, let's do something a little bit different. And I remembered that back when I got the Mini, I really wanted to do a live stream where I took it all apart and looked at all the bits and then put it all back together. Now, doing both the complete disassembly and assembly is probably quite difficult. Have I got audio properly? Yeah, hopefully, yes. So I don't think we're going to be able to do complete disassembly and assembly in one video. I just don't think we'll have time for that. But what I do want to do is take apart as much as I significantly can without having to really, I mean, we'll get into most parts, but I'm not going to take the Pinder probe into 10 pieces. It's going to stay as prep. So that's the plan. Hope everyone's doing well. I guess let's just get started. Don't think we need to wait for anything. Of course, we are doing this mostly by memory, which I don't think should be too difficult because I know what it looks like, and obviously I'm going to be doing the disassembly. So my only concern is doing a live stream whilst remembering all of that could be a little more difficult than I may have accounted for. But it's disassembly first, and that should be quite easy. Just take apart all the screws until it's in many, many pieces. So, where should we begin? It's a good question, eh? I'm thinking the best thing to do would be to first get it into the original assemblies. So, for anyone that doesn't know, this is the Prusa Mini. It's a small printer by Prusa Research. Obviously, they've not sponsored this or anything like that. And I purchased this myself, for anyone wondering. I do have a little review that I made during lockdown, which is rhyming from beginning to end, because why not? If you're interested. But today we're going to be doing something a little bit different. Instead of assembling a printer, we're going to just be taking it to as many pieces as possible. So, flexible build plate. They come in a textured and smooth format. Oh, if I give you information, I'm going to think everything. It's just going to sound like a sales pitch. This is not sponsored. I'm not attempting to sell anything. I don't have an affiliate link even, so no selling will be going on during the duration of this stream. Step 1, remove the stiff sheet. Yep, that's the easy bit. That's the easy bit out the way. I think it may get a little bit more difficult than that. Part of the reason for doing this, if anyone's wondering, so obviously this comes as a, I don't know why I started taking this apart. I said I was going to do, this is part of the sort of assembly, I suppose. Obviously it all comes as a kit, and I wondered if there was a particularly complex part of the assembly that made them decide, let's go with a kit because such and such will be very difficult to do without a jig. So maybe there was a reason, I don't know. And I thought I'd just might be a bit fun. I do use a OnePlus 6T. That's a bit of a random question, isn't it? It's even in my pocket. Yeah, I do. So this is the screen. I think the difficult bit is remembering exactly which assembly uses which screws. So this is probably 18 or something. So assemblies like this, we'll take this apart and we'll have a look at the other parts of it, which you don't normally necessarily get to see. I mean, obviously if you've disassembled your own, you'll get to see it, but because it comes as a kit, many of the reviewers won't have gone the reverse step of, oh my goodness, this is tight, taking everything apart and showing you. So that's what we're going to do. Get something for the screws and nuts. Well, yeah, but I think they use stainless steel screws. It's a magnet, and it just which is why their screws are all really soft, I think, because stainless is softer. So I can put, they do seem to be very mildly magnetic, so they might be a 400 stainless or something, but I'd much rather, like, bright zinc plated fixings don't look particularly nice, they look a little bit cheap, but they're steel, so they're magnetic, and the zinc plating is a reasonable protection as long as they're decent quality. So they can be pretty good. So in addition to this, I actually got this timer for doing live streams because I want to be able to measure how long it takes me to do the live stream. Well, not to do the live stream, I should say. How long it takes me to do an assembly. So it's a little basic stopwatch. At the moment, it's just showing the time, so you know what the time is here. And hopefully we can sort of keep that on screen during our assemblies, and you'll have an idea of how long the build has taken me. And I can also look back afterwards. It just helps me when doing a review to know how long that process took. It is a bit of a process even remembering the original assembly. So one thing I've actually not a huge fan of on this Prusa machine is the cable management. Now, it'd be interesting to see somebody like Tom's, because obviously he had one far more recently than I did. So it'd be interesting to see if they've improved their cable lengths over time rather than just mine. It looks like they've gone for the longest possible length. And yes, just gone for the longest possible length. I don't know why I needed anything else to say in there. So this has obviously got to come out. That's going to the heated bed. This has got to come out because that's also going to the heated bed. That's the thermistor. Excuse for the XXXXL. I did actually use, oh no, not the blue one. Yeah, the blue is so big, isn't it? That's a 10mm. Look at the size of it compared to the Mini. It's huge. I'm actually, these tools are quite good, but I don't like this little rubber thing that they come in, because it's kind of not very easy to get the tools in and out. It's a bit of a pain. Right, hopefully that will come out here. Also, without an assembly guide, I wouldn't be surprised if during the assembly I get so far and go, oh, I needed to put a slotted nut in there at that point and forgot it. So another thing we need to be careful of is this ribbon cable. In case it wasn't obvious, this is not any official guide of how to disassemble a Prusa Mini. This is just me winging it to do it. So if I do something that looks like it probably shouldn't be done, it's probably true. Yeah, right. Is that now separate from that? Pretty much. So I think this is much closer to the assembly. Oh. Screws come out now. And that one's out too. Right. So I believe this is much closer to what you get in the kit when you buy it. So you have, if I remember, it was a little while back, you get this main bed assembly, you get the screen, and then this. I don't think any of this is disassembled. I think that's as it is. So yes, there we go. Yeah, the jamming the ribbon cable in the extrusion seems like a bit of an afterthought, doesn't it? I'm not a particular fan either. So I guess let's start with something quite simple, shall we? Try not to ruin the whole printer all in one go. Let's switch to this one. This is a slight angle today, so sorry about that, but I am unable to change it, basically. It is what it is. So this is the LCD assembly. Evidently there's no nuts here they are just threaded into the plastic, so you get this squeak, but I mean it's plenty strong enough. In fact, it's something I also do. If you uploaded a video fairly recently about how you can go about designing a enclosure for LCD displays, very much like this one, in Fusion 360, well, rather using Fusion 360, and then you can 3D print. So it's for things like touchscreens and other graphical LCD displays. Yes, when I'll be doing some close-ups when we get there. That is the plan. We've got this macro camera, so macro lens rather, on the camera. Hopefully it will focus nicely today and we'll be able to get some decent close-ups. So they're all the same length screw, which is what you'd expect. And then of course we've got this, that comes off nice and easily. Now, I do have to be careful because I don't know how fragile parts of this assembly are. Not too fragile by the looks of it, looks all reasonable. So, let's see if we can get some decent close-up. So, for those that don't know, LDO Motors supplies the screen assembly. Well, they did originally, didn't they change something about the screen assembly? I think it's still the same supplier. Let's see if we can get even closer. There we go. So this is obviously the back. This is the bit you would normally see anyway. It's around the back, so it's not normally covered. You got, so this thing here is a buzzer. This is obviously your main connector. And then this ribbon cable here is what goes around and connects to the LCD on the other side. The chips do have text on them. I think it might be a bit difficult for me to read them though. Can't really, oh yeah. It's got other markings on, so quite difficult to see. On the side you've got this foam, not exactly sure. Normally they're just basically in contact, so I'm not sure why in this case they're not. There may be a thickness reason to do with this LCD knob, so that this height comes up nice and close, so you don't have a weird difference. That would be my guess. And then on the front you can see the button, which is the old reset button, obviously triggered by this pushable part, what do you call it, the flexible part on the front, and the main LCD on this side. So there you go. Nice and simple, that assembly, very easy to take apart and put back together. 3D printed part in there, you can see they put versions on there as well. Thank you very much, 3D Head Tutor. It's very kind of you. Are you going to focus? Got mice all over the place. You can see this is F1. I don't know if they will have changed the version for this. This is also, well, yeah, it will be revision 1 on the basis that this was pretty early on in the order cycle, so I would expect it to be an earlier version. I don't know if they've had many iterations on this. They may have tried to reduce cost, perhaps, by reducing maybe material while trying to retain as much strength and other performance criteria they have. But as far as I know, no significant changes in the LCD over time, if I remember correctly. Have I considered pimping my Prusa Mini? No, I haven't considered it. I'm thinking now, but it's probably not something I'm going to do. Main reason being, it's quite good workhorse, and I feel like if I was to play around with it, I mean, doing printed parts in other colours would be quite cool. But I don't think that's really my thing. It's not very engineering-y to print parts in different colours. It looks cool, definitely. That, like, I can see why you would want to do it, but I don't think it's the sort of thing that works for me. And modifying it is, I don't really want to, just because, as I mentioned, it is quite a good workhorse. It just does just print when you want it to print. Oh, I've got a really itchy nose. Sorry. So yeah, that's the first little assembly. Let's remember to put the knob back on. And then this is what it looks like again, fully assembled. You've got this, obviously, like indexing parts, so this is how you get that positional part in terms of rotation. Oh, there is an R2 part. Oh, I wonder if it just made that, perhaps they've changed the encoder wheel and needed a slightly larger hole. It's not quite centered on mine, so maybe they improved that slightly as well. Maybe there was some tolerance in manufacture, maybe the position of the wheel, so they had to maybe enlarge it slightly. But in terms of functional use, it's been really good, that. Let's stick that back over there. Now, which part should we do next? I think the bed assembly is the next easiest. So hopefully bed assembly is not going to be too much of a challenge. They've used weird Torx bits for the bed. They obviously don't want you to play around with it. But of course, I'm going to. I can hear something. Oh, that's all the... It's not nuts. Paul, if you'd like to get in contact about review stuff, if you'd like to send me an email, that would be much appreciated, rather than comments on videos. You can find there's a link below for my website, and then you can find the contact info on there. So where's my... Here. This is probably having these two keyboards. They do take up an awful lot of space, of prime real estate. It's quite alright, Paul, don't worry about it, just it's useful. If it's on my emails, I'll actually be able to check it and respond. So, one thing they do seem to have changed here is threading aluminium. So on the Mark III printer, these screws that hold the bed down are in a very similar pattern, obviously slightly different size, but they thread directly into the aluminium. Ooh. This is exactly what I don't want to happen. No! Where's it gone? I shall be back in a minute. Oh, come on. Where is it? Can't have gone far. Did I sit on it? Oh, crap. Well, that's gone. Oh, found it. Whew. So these are very small screws, if it wasn't already apparent. Do I have my digital calipers? Nope. I don't know where they've gone. Maybe a ruler? Nope. I reckon they're 6mm. They might even be less. They're very, very short. This. That one was a bit loose. None of these are very tight, actually, particularly. They're like barely held in. I found actually these is one of the things that did tend to come a bit loose on the Mark III over quite a long time, and does cause the bed to make a lot more sound. So if you do have a slightly noisy printer, that may be why. Ooh. So this is the underside of the bed. Let's see if we can. As you can see, this is the you can't really the 007-inch edition. So this is these are PCB traces on both sides. I didn't realise that. So yeah, it's got traces this side and the bottom side, so that presumably helps with overall heating uniformity. These are all the magnets recessed into the back, so presumably they, unless it's bonded, no, I'm not sure exactly what the manufacturing process would be. My assumption is that they manufacture the board with the PCB and then mill the holes. Hang on, these can't be... Well, this is confusing. What? Okay, so hopefully this will, even at this size, it's quite... So these are the traces, right? I can feel them this side. I know they're right here. But this has been manufactured by CNCing a hole. It's obviously not all the way through, just a slot into the top. But that cuts straight through the PCB traces. So presumably they must manufacture these with the copper on both sides? The pattern is... I'm so confused. The pattern couldn't actually work. It doesn't finish. It's very slightly different on this side. There you go. You can probably see in the reflection. There's two thick traces, which are where the power goes on the first one, on the other side rather. They're not connected on that side, whereas this side they are. This is going to take a very long time if we look at everything in this much detail. Sorry, I'm looking at this point up here. You can see the traces come back into the connector. That's really odd. Let's have a quick look under this connector. This is one thing I do remember connecting. See if there's... I mean, I've printed quite a number of hours, so let's see if there's any issues starting to occur under here. I do like this little... So, on the Mark III, the original Mark III design, I don't know if they've implemented the same thing, but they normally... So they have this like top and bottom cover. Oh, come on, please focus. Please focus here. So they have this top and bottom cover on the where the cable comes out. On the Mark III, they're just kind of two separate parts, and you have to sort of screw them together and screw them to the PCB, and then it kind of holds everything in place. Whereas on this design, there's only one screw. Well, there's two actually, but they have this kind of interlocking dovetail sort of joint at the back, so you can kind of see those angles. So everything gets kind of held in place without the screw. There you go, and then that comes off like that. Quite handy. Oh, hello. Well, that's all come out. Oh yeah, it is just one screw, sorry. All the... All the current's going through the screw. Because the copper pads are on the top side. That's odd. So these, where these ring terminals connecting to the bed, there's no bare copper on the underside. But there is on the top, which means the current is going to the connector and then all the way through the screw and then to this side. Seems a bit odd. I suppose the screw is pretty thick, like it should be able to carry that current, but screws screws are not particularly designed to carry current. That's the only aspect I suppose I would really question it from. And again, just because it can doesn't mean it should. Why is Joe going to be livid if he sees this? I don't think it's... Don't make drama out of something that's not drama. This is not perfect, but as I said, the current, it's only 85 watts, so it's nearly 4 amps, and those screws are M3, so they're 3 millimeters thick. That's a pretty decent cross section for carrying that amount of current, even though it's steel and not copper, but that's way thicker than the cables that are coming down the chain. So in terms of their capability, I really don't think that's going to be a massive problem. Let's not, as I said, let's not drama over something that's not drama. It is what it is. This goes on the bottom. I don't think there's much more we want to disassemble out of this, so hopefully I can just put this all back together now. This is the bit that's kind of cool, the way this slot's kind of back on the top. Has that gone in? Sort of in, and that's snug down over there. It's not perfect, to be fair, but it's pretty good. Yeah, maybe this would have been wisest to do on a new Mini, but I mean, this is the one I've got, so this is the one I'm doing it on. I can't be waiting like months for another printer just to do this sort of thing. You're right though, because then we could evaluate the most recent and changes. But if I get another one, then maybe we'll do it again and we can compare the two. Compare the two. So cables do use ferrules into screw terminals. That is the right way to do that, obviously. Maybe that goes without saying. They do generally stuff pretty safe. So yeah, that's the correct way to have. In fact, let me just show what they look like inside, because I'm sure they look good. It might be a good example to those that have maybe not seen how these are supposed to go. And if you're looking at doing some printer design or modification. So these are called bootlace ferrules. These maybe look a little bit overcrimped personally, but I guess I'm not an expert. So these are bootlace ferrules. They have, once they're crimped, they have a square cross section, which gives a really good contact into terminals like this. So it's ideal for sticking big cables into square holes like this one. Ferrules are also pretty cheap. They're quite easy to get hold of. You can get them in fairly decent sized kits with a whole variety of sizes, and the crimp tools are not too expensive either. So that's the bed. That was Rev 2, by the way. Well, no, Rev 0.2, so could be many changes since this one was originally made. It will have passed CE compliance indeed. Yeah, so they know what they're doing. I think I'm going to avoid taking all of the screws out of the bed, because I don't think we'll gain anything from removing those. But it is kind of interesting that they have moved away from... I need another... Oh no, I can use this. It's interesting that they've moved away from threading the aluminium. I don't know if that was an expensive process. I know typically that you don't thread aluminium as a rule of thumb in engineering. When you're designing stuff, it's just not a great material to thread because it's quite soft in comparison to steel. So when you thread into it, it tends to break the threads. Obviously, the harder, like 7000 series aluminiums are not so bad, but still not ideal. Generally better to not have to thread aluminium. So let's take apart this whole thing as well. Not sure what the first thing's going to be, so let's take the tensioner out first. Okay, Gusner, thank you very much. I shall see you soon. Oh yeah, of course. Everyone don't forget to like if you're enjoying it so far. Obviously we're not too far in. Half an hour. Cool, we've not done much in half an hour, have we? Oh, where's the OneDrive bit? I took one Allen key out earlier and didn't put it back. So let's just get that. So I think this little assembly is quite interesting as well, because if you look at the Mark III, they do use very similar-ish. I mean, obviously the rails are of similar ilk, and they use the extrusion because people like extrusion. Makes for a very fairly decent assembly. But they've, instead of having aluminium plates on the front and back like they do on the Mark III design, they've gone for printed parts, and obviously they're a fair bit smaller. But I think that's actually quite interesting change. It does seem to work quite well, and I bet the assembly is really pretty quick. It does reduce the part count by quite a bit by having these printed parts, because they don't have to screw in like little brackets and stuff for holding things. So I wouldn't be surprised if it's almost as rigid, if not more. Probably not more rigid, almost as rigid. What do I think of the Mini? I think it's really good. It's not perfect. No printer is perfect, but it is very good. It's a bit more expensive than other printers of similar volume, but it's also very reliable. It comes with loads of settings. You get good support from Prusa Research. So this will be a good opportunity for me to do some lubrication as well. Right, so rods. I believe these are 8mm diameter. It's pretty standard. Yep. For length, these are 278-ish, 279-ish millimeters. It's probably not a very accurate measurement. I'm using a basic tape measure after all. That almost looks like 278.5. So 278.5 is about the length of both of those. These M3 screws are obviously for that tensioner. And then you've got this fairly complex looking part. I believe all the parts that they print out, well, all of the, I should say most of the parts are PETG. Their top surface tends to be not super great on their parts. I mean, it's odd that a lot of their print quality they provide in parts is not super great, but that's because they're printing at literally maximum speed to try and optimize the efficiency of the farm to make as many printers as possible. So you do generally tend to be able to achieve better print quality than what you see on the parts that they provide, because you don't have to worry so much about the time. Unless, of course, you're a business, in which case you do. So it's actually quite light, that part. Got the bed assembly in here. Let's take this off. This should be easy. I've lost my 2mm hex. I put it down somewhere. Oh, silly me. Oh, bugger. Where did I put it? Somewhere stupid. Has it rolled under something? Yes. Are those tubes or solid? Oh, for the steel, they're solid. We can check that they're decent hardness as well. So one great way that's very easy, it doesn't tell you the exact hardness, but it tells you if they're hardened, is to use a file. If it's a hardened material, so if these are hardened steel, let's talk to the camera, there we go. So if these are hardened steel, when you use a file, they will just kind of glide across, and they might leave a very, very small mark depending on the hardness of each of these. But if you can like gouge out chunks, then it's not hardened. So yeah, it's not leaving, it's taking some of the dirt off of the file, but it's not really leaving any, in fact, usually 0 marks on the actual steel. So that tells you they are hardened. There's basically no lubrication on them though, so they definitely need to be lubricated, which is why I brought that over. That'll help reduce the noise as well. Now, lubrication can be quite difficult during like running, because these are sealed bearings. So their entire design is to prevent things from getting in the ends. They have this little rubber seal that seals around. That's what this is in here. So this seal is all rubber around the inside here. Well, it's a soft polymer material. It makes a seal, so anything that touches the rods, like bits of hair and dirt and grubby stuff like that, just gets pushed along by the seal and then out the way, rather than going into the bearings and causing damage. So trying to lubricate them from the outside is really quite difficult, because if you just put oil on the rails, the wiper will just wipe it away. So generally you do need to do some level of disassembly in order to get in there to get any decent lubrication. I'll try to remember to do that lubrication before I reassemble it. So there's another 3D printed part under here. It's again revision F1. Not really sure what the letters stand for. I've seen R's and B's and A's and F's, so could mean anything. I'm sure they've got an internal code and they know exactly what is what, but that's not shared, so it doesn't help me. So you have this central screw in the middle, which is for this center post, which is nice that you don't have to deal with those two separately. I mean, it's good that you can deal with the two separately instead of having to screw them both all in at the same time. So this is how the belt attaches. It just simply slides in. Do I want to slide it out? This is the question. I kind of do and I kind of don't. So we should do this on all the machines, I think. So this just kind of slides in the end like that. And then you can push it down into that gap with something that's reasonably small, but also not too small. That does stay pretty well. That's then allows plenty of tension on either end without anything coming out. Oh, hello to people that have joined recently as well. Welcome back. Yeah, the sound, when you can kind of hear whether they're scratching into the metal or not. And I think they ring a little bit differently as well, but maybe that's just me. So yes, I've forgotten which way around this went. So, oh no, hopefully this is symmetrical. Oh, Adam, you fool. See if I can go back on the stream very slightly in here. Oh, I think the open side faces the 2. So hopefully that goes like that. It's not super obvious for the preview that I get through YouTube. Oh, here we go. Oh no, the other way around. So open side faces that way. That goes down like that. Let's get this all back in before it all falls apart. What? I didn't say you're a fool. At least I don't think I did. Oh, you're saying because I am? Yeah, I'm the fool. Right. So this is what the extrusion looks like. So I think these are 30 by 30 millimeter. You can probably just see them just as well from there, can't you, actually? Yeah, these are 30 by 30. I believe these are from Mizumi, which is quite difficult to get hold of, actually, in the UK. Because Mizumi UK/Europe only sell to businesses. So you have to have, I think you have to even be VAT registered. So technically Vector 3D is a business, but it's not VAT registered and it doesn't have to be. So without a VAT registration number, you can't buy from them. They just don't bother. Presumably because they just don't really want to deal with selling to consumers and DIY people. They just want the big orders from big customers. This is really tight, actually. Is this table support made of aluminium? I'm not sure what you're talking about. I did notice, Adam. Yeah, there we go. So that's what the extrusion looked like. As I mentioned, these are 30 by 30, 261.5 millimeters. Again, measured with a tape measure, which could be out by a bit. It's not exactly a premium tape measure either. Nope. This assembly seems quite simple though. I don't know how much in terms of what they have in terms of jig for assembling these things and how important the alignment is, but as far as I remember, there's not much that determines anything by the rotation. Actually, that whole assembly bolts to one of the extrusions, so maybe it can be quite important that these are parallel/perpendicular. How much of it's 3D printed? This one, quite a bit actually. I mean, there's quite a bit that's not printed as well. I would say more than your average printer nowadays. A lot of the Chinese printers are using sheet metal parts now, which is good to see. But I think part of the Prusa brand, if you like, is to print the parts. They have their roots in rep wrap, obviously, so I think that's why they like to stick with the printed parts. I think it's also actually quite efficient for them now that they've got a huge farm up and running. They could probably manufacture faster if they didn't use printed parts, but I think it takes away as I said, it's part of their branding now to use these bright orange and black printed parts, so I don't imagine they're going to change from that anytime soon. Last part here is this motor assembly. Interestingly, the stepper motors that they use all have integrated cables rather than others which sometimes have connectors. I think for kits it's fine to have integrated wires. I mean, they will plan them out and it makes it much easier to assemble. One less connector. But for personal use, I do tend to enjoy, or prefer I should say, ones with a connector here, because it makes things a little bit easier to handle in my mind. So I believe it's LDO motors that supply all of the motors as well. So you've got Y-axis motor there, and then you've got, see if we can count the teeth. This could be difficult. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 tooth pulley. That'll be a 2GT/GT2, 2mm a 2mm pitch, it's 6mm wide belt. Actually, while I'm here, I could probably replace this with the Gates belt. I've got a Gates belt because Prusa now use Gates belts, and they didn't when I bought this originally, so let's take this opportunity to do that. No, I'm being stupid. That's for the Mark III. They probably use, do they use Gates belts on these as well now? I don't know. Maybe not, because they're aimed at being cheaper, so maybe they are sticking with these. Maybe that's a way that they found to make the Mark III sit that kind of at that higher price point by having Gates belts. I don't know. Maybe they've come to an agreement that makes it cheaper for them. I have no idea. But either way, this at the moment, as of when this was delivered, which was I think November last year, quite a while back. So maybe they do now, but they didn't at the time. It does allow them to test their printers a lot. That is good. That's a good point. My concurrent viewer says 0, but I'm guessing it's not actually 0. Yeah, I think the stream page is a little bit broken, but that should be okay. We're fine. I'm going to actually go around these bed screws and just make sure that they're tight. They've been on there for a little while now. It does undergo quite a bit of vibration, so just during general use, obviously. I'm going to just double check that they are still nice and tight. Yep. Oh. Oh. How on earth has that got stuck on there? What the dickens? Yeah, maybe we won't do that then. 64 watching. There's 438 playbacks as well. Don't forget to like, guys. It does really help me indicate that the stream was informative or useful or entertaining or not. Right, I've forgotten which screws go where, so let's get some stuff back together before we forget everything. I say we, I mean me. Oh dear. I can't even remember which way around that cable's supposed to go. Probably that way. There does seem to be a helpful notch to get that in the right place. I think this was probably this screw. It's nice and short. I wouldn't be surprised if I reassemble it wrong at some point, but And my video angles being absolutely terrible. Kind of forgetting about... The more I enjoy doing the actual like assembly and stuff, the less I think about the camera, which is probably to the detriment of the audience, so I do apologise. So that's back in there now, that's nicely aligned. Hopefully that wire is going in the right direction. We should be able to... I'm not going to take these apart purely because I know that the way that you tighten these can be a right pain and it's not worth the effort, quite frankly. The idler pulley we've got in there is a fairly solid one. Let's have a quick look at that. That should be fairly easy to get out. Held in with a nylock nut, this one, so presumably it can come loose if you don't have that. So you've got a... man, focus is the worst. This is the bearing pressed into a piece of milled steel, aluminium probably. Steel? I'm really not sure. I'm trying to feel the weight, not just throw it around. It is very small, but I'm not sure. Could check if it's magnetic. Yeah, I don't think... It's either stainless steel or aluminium because it's not magnetic. The little bearing on the inside is, that's steel. The rest of it isn't. Oh man, this is... Focus, please. There we go. That's what that looks like. Let's get a couple of dimensions off that, shall we? Outside diameter is approximately... Oh, I'm just going to try and get some calipers quickly. It's going to be much easier to measure these little things. Pretty sure I have some in the other room. I shall be back in about 30 seconds. No more. So here we go, got some calipers. They're not the very best in the world, they're pretty cheap, but they're good for getting an idea of what the dimensions are. They're just not perfect. So diameter 17.8, maybe 18-ish mil, something like that. 17.8, 12 in the middle, 9 millimeters wide, 6.9 on the inside, 6.75, 9.94. So yeah, fairly standard kind of part. It looks a little bit better made than the standard ones you might buy from AliExpress, but it's still probably a fairly mass-produced part, potentially from China, I don't know. Doesn't really matter where it's from, to be honest. It looks of reasonable quality, so that's good. What screw went in here? I think these are all the same length, so yep, one of these, any one of these will do. Let's get the belt in though, because that's not going to work very well without a belt. So, what we got now? I think we can probably try and get this all back together, hopefully. I think these are quite interesting, the slots that hold the rods. They've obviously got this cut down here, which presumably provides some spring around the hole to make sure it holds kind of tightly. But it's also like sealed on the back, so that would be preventing much flex from happening. So I would guess it's to do with that, but I'm not sure how effective that really is. It's also strangely close to the top, isn't it? It's like there's not much material around the top here. obviously it works fine. But it's just interesting that it's so very close. Obviously that means your bed height is nicely close to the rails, which gives you good bed stability. Probably help with overall print performance, keeping your bed low. Also probably helps with maximising your, or almost certainly helps with maximising your build volume. So how do we put this together? I think start with these extrusions. We've got to make sure we put the, so I should point out this as well. So these large bulges on either side, they look like they're just for, come on, please focus. They look like they're just for strength, and in part they probably are, but they're also dimensioned to fit the extrusion. So I reckon that's how they do their alignment in order to get things consistently in the right place. So as you see, as I put this in here, that notch on that part kind of fits the extrusion, and then it all just slots. It kind of, you have a mating face in that direction, one in that direction, pushing in, and then you can put your screws into the end. And I put that in upside down. Yes. I mean, obviously when they do their assembly, it probably doesn't matter which way up. Hang on, this looks confusing now. No, this is okay. When it's originally made, I don't think it would matter which way up it goes, on the basis that, oh, there's loads of shite in this hole. On the basis that there's no directional, they're axially symmetric around the center. So it's only because after you you add those plastic rubber, the soft feet are added by the assembler, the user, the end user. Man, words are difficult. I'm going to actually try and clear out this hole a little bit because it's being a bit difficult to get the screw in. Oh, my screws look a mess. Oh man. Now I'm going to need the drill, which is also in the other room. I'm working on a special project in the other room, so there's tools in the other room. I need to go get the drill. Up again. Back in 15-20 seconds. I may have just dropped to the drill, but hopefully it'll survive. Oh. We're not going to, I'm just going to open the holes up a little bit. So I can't get the screw in. Problem sorted. This should go in much easier. I imagine they do a similar sort of process when doing the assembly originally, but it would have been done at quite a pace. And so obviously it's never perfect, but it would have obviously been sufficient to meet their standards. These are good quality Allen wrenches. They're Wearer tools. They're quite expensive, but they are good. They have a ball end, so that can be useful for doing stuff from an angle. And then they obviously have this normal end. They've got kind of special features, sort of. They're not quite the standard hexagon shape, and it helps get a bit more grip. If that's interesting to you, then go ahead. Do I have? I don't think I have an affiliate link for. Maybe I should get an affiliate link for those. I do recommend them most streams, I think. Hopefully there's a link in the description to my website where I've got equipment, but I don't think I've put tools on there yet, so that's something I obviously should get on top of. Righty ho. So that goes that side. We need to be careful. This goes here. These two go in here. So we need to be careful now which way round everything's going. Could it go that way? And it could go that way. I think it went this way, so we'll go this way. And hopefully everything will be fine. Lubricant. Just remembered in time. I'm just going to use a basic thin, this is a multi-purpose 3-in-1 oil. Silicone based stuff is probably better, but this is nice and quick and easy to apply. That stuff can be a little bit difficult to get into all the crevices. So I've just applied a decent dollop to the inside of the bearings. Kind of want to wipe the ends off of these. Let's just do it by hand. Again, using a cloth to do this would probably be better, especially if you don't want dirty hands. Should help with lubricant for a little while. I think that was how that assembly went together. Well, this now doesn't go back, so that's not ideal. Come on. Oh, I've got a problem. This needs to go down here. So the question is, why is this not going in the end here? That's a nice, oh, that's good. I like it. I like it, I like it, I like it. Let's get this in here. And we're almost through the whole bed assembly. I might have done, but I also might have not done. If I have, I've probably lost it. I've got plenty of different lubricants, so I don't think that's going to be a problem. Sorry, just left the oil in the way. Right. Getting there now. Have I put this on upside down? I think I might have done. It goes up the other way, but that should be easy to sort, so that's fine. Does make me wonder if I've put the carriage on back to front. Hopefully not. Yeah, we talked about changing colours earlier in the stream. It's just not really my thing. Well, why is this screw? I must have picked up a different screw, did I? Why is this screw suddenly not long enough? That makes no sense. What? Oh, I think it's pushed the nut, hasn't it? That's what it's done. There we go. Oh no. A fool, come on. That goes in there. And that slips into here. 2 screws in the back. Yeah, I mean, I could have printed new parts, but it's so much of a hassle. Live streams, I wouldn't be able to do a live stream and a video every week if I did loads and loads of prep and stuff. So I try to make them as easy for me as possible, and then the videos are much more involved. The videos are the big learning opportunities really for me to provide. So, I don't know if it's up to the Prusa standards. I don't know what the Prusa standards are. But for my standards, I think that's what we'd define as good enough. Now we can stick the bed back on the top. And that's the bed disassembled and reassembled. Interestingly, I've done it in a much more sensible way than I initially considered. I thought I was just going to tear it all to pieces and have all the pieces laid out and then put them all back together. But this way of doing a little bit at a time and then putting it back together is definitely the easier way of doing it. So now we need that Torx bit back again. What Torx size is it, out of curiosity? For everyone that wants to know, it's Torx 10. TR10. Oh man. This is why we need steel screws, because that's where I've fallen in the slot and I can't get to it. Ooh. So there's probably a good order in which to tighten these. So what I'm going to do is keep them all loose until I've put them all in, which obviously ensures that they're all going to fit. Then once they're all in, I'll tighten them in the pattern that's suggested. Oh, well, that's weird. So they are very, very slightly magnetic because they clearly stick to this magnet, but they don't stick to the magnet on the screwdriver. Would ASA be a good filament for hot-end parts? For things like fan ducts, yes. So ASA is basically like ABS. It's not quite as temperature resistant. It's also less smelly. It's a little bit easier to print, but is very equivalent in many other ways from my experience. I wouldn't say I've done significant material testing, but from my experience of printing the two, they are very similar. So in places where you would typically use ABS, replacing with ASA is normally okay. Yeah, obviously if it's touching something that's actually really hot, then no. PC blend also, yeah. PC blend is even more temperature resistant, I believe. Not by a lot, but I believe it is. I'm hoping this is going to pass all the self-tests that happen. Otherwise we do have a problem. So let's get that back on. In fact, I don't think I had that on when I started the disassembly, but there we go. That's now on there. Let's stick the bed out of the way. Now I've got arguably the most interesting part, which may take quite a little while, and that's this whole gantry system here, because this has lots of bits all over the place. All full of stuff. I mean, peak's even higher temperature resistant than old temp, as far as I know, but like things start to get a little bit silly when you get that high up. Interestingly, for anyone that's purchased Prusa Mini's PETG, that actually prints really hot. So the suggested temperature for their PET is between 240 and 260, whereas I believe a lot of PETGs are typically less than that. So I would say normal temperature for PET is like 230, 235, but they want 240 to 260. So if you're like, you can print ASA sometimes at 240, 250. That's like normal for ABS rather. 230, 240, 250, somewhere in that region. So you're starting to get PETG that's equivalent melting temperature to ABS. Although maybe after it's printed, the plastic deformation temperature is a bit lower. So maybe don't use it as a hot end fan part thing. Right. I've been doing a lot of talking, my throat is a little bit sore. But we've got this one part left. Ooh, I do want a printer that can do all those things, but I don't want the effort of having to build it this time. I built too many printers and they take a lot of time. If I was just a hobbyist and not doing YouTube, then that's all I would do, is build printers. but because I'm doing YouTube as well, it's not really very time efficient. So, again, obviously no instructions on how to disassemble this, so we're just going to wing it. There's going to be lots of hoping going on here, because it is quite a complex assembly. I think we're going to have to rewire the entire control board, because otherwise, yes. So I guess we can do that first. Let's take all the stuff out of here. Let's try and do this back here. You're going to focus on, no, you're going to focus over there. See you, Paul. Thanks for joining. Probably should have taken pictures of where this stuff goes. Let's plug them back in. I'm going to take a few pictures on my phone first, because there may not be wiring references that are great online for this, so best for me to make my own. This is quite a good tip for anyone who does some disassembly or assembly stuff themselves. Taking pictures of stuff before you pull it all to pieces can really help when you're putting it back together and things are starting to not go quite as you planned, or you forget things, or you had to stop halfway through for some reason, or just other reasons. So yeah, it can be really, really useful. Just a couple of pictures to help you with the difficult bits. Yes, the cable management is not great, and I suspect this is in part due to early revision. They hadn't determined exactly what the cable lengths need to be for production yet. I would hope and partly assume that newer printers, such as the one that Tom currently has, are wired a little bit more efficiently, but I can't be sure. I mean, I could ask him probably, but until I do that, I can't be sure. So that's everything unplugged from the board nearly. Ribbon cable. It's not super difficult. I don't like this little power switch also. I'm probably going to break this case at some point, just because it's not very forgiving. Right, hopefully that's not damaged anything. So this little power switch uses, well, they're called quick disconnect red terminals to connect to the control board. Let's remove the control board. This is really awkward to do with all of this still here, but screw it. I mean, unscrew it. Great joke. It's a little bit unfortunate that two of these parts are green and everything else is a nice black, but at the end of the day, I don't think that really matters. We're going to have trouble with this. Looks like all the screws are out. We might need to actually remove the screws rather than just unscrew them. Let's lay this down for a second. What I'm going to try to do is poking them through from the back. Hopefully that'll give the control board itself a little bit more room to wiggle out. Oh, because it is quite snug in there. very snug in there. Hoping these nuts are not going to fall out while we do other things. So this, if you're not already aware, is what the body control board looks like. So this is the Prusa designed 32-bit control board for the Prusa Mini, obviously. Stepper drivers, you can see 2209s or 2208s. I thought they were 08s, but they look like 09. So small it's difficult to read. I think they're 09. Well, it'll say on the website exactly what they are anyway, but this is their 32-bit control board. It'd be really nice if these were black and not green, but it really doesn't matter. It's not going to change anything in terms of performance. It's just an aesthetic thing. Obviously, you've got your power input here at the back. This is the Ethernet. I'm not sure what this little isolated part here is. It's got a separate little controller, presumably given its proximity to here. That might be for the Ethernet controller or something. I don't know, sorry. That's my guess. SMSC is what's written on there. There's a part number as well, but it's too small. You've got USB ports down the side, so you've got the full size micro USB reset switch. Motor connectors along the bottom here, and then you've got, what are they in? Like touch sensors, fans, and other things down this side. This is for the screen. So you can see there on the back, Prusa Buddy 2019 version 1.4. Yeah, actually, that's kind of weird, isn't it? They're all labelled on the back. So every single thing, in fact, is labelled on the back. LCD, fan 2, fan 1, filament sensor, Z-min, motor X, Y, and Z. But not on the side where you can actually read it once you plug, or is it? No, they're not labelled on this side. Well, I hope I'm going to get everything back in the right order. Let's take a picture of it on this side while we're here. Oh, did I get... I think I might have got grease all over my phone. Take another picture. All 6. So let's get that out of the way. Hoo-wee. Right, next. Take the filament sensor out. That's really quite easy. I thought it just pulled out just like that. So this is like a add-on part that you can get. Adds a filament sensor. Its usefulness depends kind of on how you print, what size. If you're printing at large sizes quite often, then I find that extremely useful. But if you're printing lots of very small things, it's generally not the end of the world if one or two of them fail. Oh, hi Tom. Why the teardown? Why not? I was supposed to have another printer build. There's really no, like, I'm not trying to fix anything or anything like that. I just kind of wanted to do it ever since. I guess I wanted to do it from the point where I knew that the kit was not a, like, full kit, but a kind of partial kit. I just like building things, so, you know. Seemed kind of like a bit of fun just to, I guess tear down is maybe a bit more aggressive word than maybe I wanted to use. I'm just disassembling, taking a look, putting it back together. Doing a bit of lubrication on some of the bearings as we go, but I'm not like changing anything. It's just have a look, really. Have a little look at things that you can't normally easily look at. These are tight. And that's not going to go in. This is a challenge. Oh, I think we've got it. Does it have Wi-Fi? No, so let's show you on the control board. Which port is it? Must be this one. So Wi-Fi is not embedded on the board, but it does have capability to utilize it. So by that, it means this header here, I believe, is for an ESP, what's the number, 8266? It's basically, if you look up ESP Wi-Fi module, you'll be able to identify it. It's a very widely used add-on module for Wi-Fi. You can plug that in and then you get Wi-Fi, but by default it has the Ethernet port. I think for most people with maybe one printer or a couple of printers, Ethernet's fine because having one Ethernet port to a location is generally quite easy. But when you have lots and lots of printers, I suppose if you have loads of printers, then Wi-Fi becomes a problem because you probably have like interference because you've got so many devices. Why has that not just come off? Reasons. But I guess you'd start to need like switches. Did I? Yep, that's out. Oh, this clamps on the things, doesn't it? God, the chances. I think the chances of me getting this all back together just right is getting more and more slim by the moment. Especially if I forget something halfway through. Where's the bit you break off? Oh, okay, I can show you that too. So, let's get the board back again. So, it's generally known as the appendix, I believe, after the bodily organ, which is somewhat useless and often removed. Here is that part. It's very, very small. It has that little exclamation next to that ESP port, in fact. So that's the ESP, and that's the part that you need to break just above where right there where the exclamation mark is. Obviously, it's quite difficult to see, but hopefully you can just about. I don't know how close the macro will go. There we go. Sorry for the movement, and you probably don't want to see my fingernails, but there it is. So if you want to flash firmware that's not by Prusa Research, you have to break that part of the board. I'm not certainly sure exactly how you would do that, or the best way to do it without damaging anything else, but presumably they've designed it so I presume you put like Allen key in there and just push it down, it'll break it out, and then you'll be good to go. These, the pretty coloured Allen keys, yeah, they're nice. But it does make it more obvious using nice Allen keys when there's cheap screws because, yeah, they tend to just destroy the heads of the screws if they're really cheap, buttery screws. I think my assembly or disassembly order is not particularly great. This is still not going to come out. It's these screws here. So I'm pretty sure these 4 screws are clamping onto these rods, which is what holds this lot together. So if we simply loosen these, ta-da! Boom. So, oh, shit. So, that's quite a neat little package, isn't it? So you got this, on this end you got this really kind of dense It's not that dense and it's not that thick, but it's much thicker and sturdier than the rest of it. You've got this kind of much thinner construction around the remainder where it's just housing a control board. So this is your structural end, and this is the part where it attaches to the frame. This is obviously the part where the rods go, and the center is where the lead screw, well, there's like a recessed space for it, but it doesn't really fit or touch that in any way. Yeah, it doesn't actually use it. The screws obviously in the end there, which I'm going to leave in. I'm not going to remove those. I don't think there's anything to gain from taking some screws out. That's how that lot goes in there. Quite an interesting kind of clamp design. And we'll put that there and then try not to forget about it. Yeah, I mean, I would definitely agree that for when you're like using computers and stuff, I always go for Ethernet over Wi-Fi. There's nothing worse than a slightly dodgy Wi-Fi connection. But for printers where your main purpose generally is just to upload a file, I wouldn't be too concerned about using Wi-Fi, to be honest. This is a nice aluminium plate. Only piece of plate aluminium sheet metal fabrication that's used on this printer, I'm pretty sure. So this is kind of, it connects the Z to the Y axis, the whole bed assembly. Helps keep it all rigid. And those rods really fit to this quite tight. It's a really snug fit, so that's going to help with alignment of those rods, I think. It really is snug, I guess is the right word for that. 8:30. We're not doing too badly, hour and a half. It's going to take quite a while to do this and put it all back together, but okie dokie. Oh, what order am I supposed to do this? I mean, I'm not supposed to do it, so I mean, there's that. So you got these little covers that go over the extrusion, help with a bit of the old cable management. I mean, for general users, it does just keep the wire out of the way of the motion stuff, but for your normal people, I suppose, it makes the product look more professional because there's not wires. More, well, I don't know. You know, I think, hopefully you know what I mean. Like, it makes the whole thing look a little bit tied in, maybe a bit more professional. Helps people justify the price before they've bought it and enjoyed using it. So that's another piece of extrusion. Let's get a quick measurement for this one. It's probably still 30 by 30. Makes sense to use the same size. And then overall length, 288. Can't remember what the other ones are, but this one's about 288. It looks like 288.5, but I think this is half a mil out because, well, that looks like 29 and it's 30 mil extrusion, which is going to be very close, so maybe it's 1 mil more. Yeah. Tape measures, eh? Rubbish. They've got this little sticker on the top here. I believe having that is part of the CE marking to mention documentation, mains and assembly, and then not putting your hand by dangerous parts. What do we want to do now? I reckon we want to come around this side, try and remove this, so we can slide these two assemblies apart from each other. Slide this nut all the way off. That's an interesting noise. Oh, it's just the lead screw, okay. Probably shouldn't do that too many times. Ooh, blimey, that's heavy. Jeez. I guess I shouldn't be surprised. They are 10mm steel rods. It just seems remarkably heavy. Well, I suppose it's 2 10s and an 8mm steel rod, so yeah. It's a pretty heavy little assembly, this one. Take this out of the way. So just the one wire on this one. This is the Z motor. Let's see if we can take this apart. That close-up camera is just the right angle, isn't it? You can see most of what I'm doing. How wonderfully has that worked out? These rods, so it changes. They're different sizes in different places. The Y-axis ones we measured earlier at 8mm. These ones look like 10, so let's double check. 9.99. Yep, those are 10. And then your lead screw, as normal, is 8, and the ones on the X-axis also 8. Obviously, the Z's got to deal with quite a cantilever for the X-axis, so that's presumably what's impacted their decision to go with 10mm rods. And it may be a part psychological thing if it's not fully engineering reason. I think people would have expected 10mm rods, so if they didn't, then people will go, oh, that's just going to be flimsy, whether it actually is or not objectively. So I think they may have done it for that reason as well. Gonna get cloth quick. Gonna wipe some of the gunk off these rods while I'm working on them. Just a bit of very basic maintenance. And then we'll re-lubricate when it all goes back together. So yeah, 10mm rods. Ooh. Again, very much like the design on the the design on the Y-axis and the bottom of the Z. They use a small clamp design to ensure that they have a good snug fit. We can check again for hardness like we did before, so you can simply rub the file along it. Yeah, just glides straight off, no impact at all. So you can tell. There you go, that's really obvious now. Damages the file probably more than anything. Ooh, very nice straight rods. So that's cool. You got this nice, fairly complex little part which holds that assembly all along the top. Nice. I do like these little kind of wire management stuff that they do. It does work really quite well. And then quite intricate design. They've got these clamps that obviously hold everything together. This recess, this large recess circle that I'm trying to point out here is for the top of the NEMA stepper motor. Only 2 screws in the NEMA, it's probably sufficient. And then obviously you can't because the rods are in the other direction. So there you go, there's that again. Part number F1 again. Sorry, not part number, that'll be the revision number F1. Wow, how many people expect me to rhyme now when I do anything to do with Prusa? I'm not having a go, don't worry. I get a lot of people saying, oh, just rhyme. Although I'm English, my rhyming English is not that great. It took me a little while to make that video. And I definitely couldn't do it like a rap just off the cuff. That would definitely be very embarrassing. I don't think anyone would want to see that. Ooh, okay, we're fine. So, lots of parts suddenly occurring now. We've got stepper motors, Z motors. I'm just going to cause myself loads of issues and make sure that I don't reassemble anything. That goes with those, that goes here. Those, I think, went with that. Those, no idea where those go. They're going to sit just there. I have got everything sort of organised on the table here, so hopefully that will help. Hopefully, maybe, I don't know. Previous experience tells me it helps a little bit, but not completely. Better than nothing, but not better than actually being careful. I'm glad you enjoyed it. It's quite funny. The comments on that video are pretty hilarious for me. Some people are like, well, that was amazing. Best video I've ever seen. Every video you do should now rhyme. And some people are like, just stop rhyming. That was rubbish. I'll never watch it again. Unsubscribe. It's like the variation in comments is just vast. But I enjoyed making it. I probably won't do another one because, honestly, I think the video overall would have done a whole lot better had I not done that. But there you go. Can't win them all. It was good fun, so it was worth it for that. How the hell do you disassemble this? I'm trying to identify what the first move to make is. So I'm going to take this tube off quickly. I will just mention actually this Bowden tube. There's one thing I really like about it. There's one thing I really dislike about it. Okay, the dislike is really not that big a deal. The like is these coupling fittings, proper decent compression fittings. These are wicked, like super, super wicked. In fact, I think I might be wrong about the thing I disliked. I think I thought I disliked it. Right, hang on, let's just get through it. So these compression fittings, the reason they're good is because they don't rely on that little push fitting on the top. That little push fitting that you have on those normal PTFE couplers you find on like the Creality printers and nearly every other printer, where you push the PTFE tube and you have that little locking collar and stuff like that. The first problem you have is they tend to have a bit of wiggle room in them, so they can move in and out, and that's generally not great. It can cause some print issues. So that's one reason I don't like those. The reason these are good is that it doesn't matter. Oh, sorry. The other reason I don't like those is when there's filament on the inside, most of the time you can't push the coupling in, so you can't take it off. So if there's filament in there, you can't remove it. Whereas with these compression fittings, because it doesn't rely on anything to do with what's inside the tube, this compression can be screwed and unscrewed with filament inside, which makes it much easier to access, not necessarily mid-print, but if like the loading procedure didn't go quite right or something like that, it's fairly easy to take this whole fitting off and you can access either end. So yeah, that's that. Let's see. Oh, here we go. This will help. So first thing I want to do before I do that, actually, there's a few zip ties here. I was going to try and avoid cutting zip ties, but in fact I'm going to leave the zip ties where... Oh, why is that motor in the same... I guess that makes sense. Oh, that's Mr. Disappointment, that is. Okay, well, that is what it is. Maybe this was not the best idea to do this way round. Okay, we'll do something else first. Let's just try these. No, not those. These screws at the end here. I'm not sure exactly what these are going to remove. It might be these rods. I think it's probably these rods, actually. Actually, the more I look at it, the almost becomes very certain that it's almost certainly those rods. Again, using a very similar clamping mechanism to hold everything in place. Yeah, I think the cringiness of the rhyming was what put people off a bit. Obviously, it wasn't necessarily intended to be particularly cringy, so a bit of a failure on my part there, I guess. when I was making the video, I was thinking in rhymes for weeks. So yeah, I understand, but it's not something, it's not like, thinking in rhymes was not particularly practical or useful, so it's not a habit I really want to keep, to be honest. That's interesting. You can't take, I was going to pull that out that way, but you can't pull it out. So, okay. That's not, oh, what's those screws for then? Oh, those, yes. What? This has not gone quite as planned. This assembly is very complicated. The team that assembles this must have a bit of a hard time. In fact, to be honest, once you know, it's probably quite simple, but doing it live without any guide, not quite so simple, I must say. Let's release the tension a little bit just in case the spring pops out somewhere weird. Oh, ha! Boom! Well, that's nice and easy. That makes the whole process much more simple as to see what's going on. So you've basically got this little module that's just the extruder. No, it's all zipped up. Forget that. Let's get this all back in. I was going to take it out, but there's another zip tie at the end, which I want to avoid cutting. So I'm just going to quickly put these cables all back in this little sleeve thing. Okay, that's I've already made a meal of that. It was something like that. So thank you very much. Pull the extruder first, then the X motor. I think I've got it now. Thank you. That should be just like that. Thank you very much, Snell. I'm glad you think so. I think my content is, well, as the way with things like this, it's a bit of a niche. I think the people that enjoy it do really enjoy it, but it's just not many people's cup of tea, so there's many people that don't enjoy it so much, which is fine. Best quality 2 in, 2 out. 2 in, 2 out. I mean, like, I don't know. I don't really use any. This is all just coming apart and I don't know what goes where. This is when I need to be a bit more careful about what I'm taking apart. Oh, that's fallen out. That's that fallen out. Oh, it's going to be a miracle if this goes back together. Hey, we're there. That bearing's rather gunky. Gives this a good little clean out if we can. I'm not sure I want to press that bearing out just in case it's very difficult to put in. So we've got, looks like a lot of these screws are all the same length, so that'll make reassembly a little bit easier. Well, it will make assembly easy. Yeah, they're all the same length. Easy peasy. Anyone could do this. I don't recommend doing this. Honestly, there really is no need for any normal person to do this. I'm doing it for entertainment purposes. well, for your entertainment as much as my entertainment. But I don't think, like, if for general people, it's not necessarily something I would necessarily suggest you need to do. Okay, Snell, thank you very much for joining us, and your very nice compliment. I shall see you again soon. Were you one of those kids who liked to disassemble stuff and then was not able to put it together? How dare you? I'm pretty sure, well, yeah, I mean, when I was very young, sure, yeah, I just took stuff apart and it never went back together. But it wasn't long before I'd take stuff apart and then put them completely back together. I think some people just find spatial memory really quite easy, whereas some people find other memory types easier, so. Like, one of the nerdy child things I've done is I challenged myself to disassemble something and put it back together the day after. So I took apart a laptop to like every single screw, which is quite a feat if you've ever done that. All by memory. All the parts on the table. Next day, put it all back together without hassle. So, yeah, that was a bit of a humble bag, that, wasn't it? But my point is, I don't know what the point was. Yes, it's doable. So this is what the extruder looks like. So I'm not going to bring this any closer than it is. You've got a hobbed gear, or a gear tooth on here. It looks very similar to how a Bondtech would be machined, but as far as I know, this is not a Bondtech gear. It also has no teeth for touching filament. This is the gear that does the main bulk of the work. So you've got, oh, come on, please focus. Focus here, please. It doesn't like orange filament. Orange filament is the worst for focusing on. So this large gear is what touches the one on the extruder motor, and that's the, well, it's the power gear if you like. And then you've got the small teeth in here, which is quite difficult to look at. Let's see if we can get really, really close. Oh no, it's just going to focus away instead of closer. Come on, let's focus closer, please. How close can we get? How close can we go? There we go. So you can see the filament touch, the filament teeth. What's the extruder teeth, I suppose. They're really quite fine compared to something like Bondtech or many other extruders. But from my experience on the Prusa Mini, they do seem to still work quite well. So again, it's not necessarily something I would suggest you need to look at or change, but you may want to if that's the kind of thing you'd like to modify. And of course, this is a smooth shaft either end, and then you got 625 ZZ, so very similar to 608. But there's a bearing each side pressed into the... I really wish this would focus quicker. There we go. Bearing pressed into each side. You can see F1 version. So the filament path, for those interested, let's see if we can show you a bit what that looks like. So... yes. So it looks like, as you look at this, that the filament's going this way, up this gap. Up here. This way, but it's not. So this is obviously the connector for the Bowden tube, so that compression fitting. So it's coming through here. This is where the, well, that bearing's where the one shaft comes through. That's where the space for the motor shaft, I believe. And then there's a hole in, this is where the filament comes through. That's why that like sharp point is here. That's where the filament will get grabbed. There's a hole down in here, and that comes out the bottom down there. You can see there where it goes all the way through. So that's your filament path all the way through that part. all the way through, straight out the bound tube at the other end. Quite cool, I think. It's quite a complex little part, but also quite neat. Again, I think this is a reasonable level of disassembly. I hope you'll agree. I don't think we need to pull those bearings out to call it a complete disassembly. I think they've been pressed in with a tool to make it easy, and I don't have that tool, so I don't want to make a mess of putting them back in again. So yes, that's that. Now this bit I think, going to put back together a little bit before we go any further, because otherwise I am going to forget things and we're going to have some real problems. Doing this on stream is more difficult than I had imagined. The problem I'm having is knowing which way the wire's got to come out of the motor. That comes out that side as that goes down here. It's just, we're going to map it out on here. So that goes in here. That's going to go that way up. No, that's going to go that way up on here. Oops, that's another screw I've lost. That's going to come in here. But I think that's going to go this way up. Well, they were diagonally though. So that's going to capture a little bit up there. Yes, that's where that went, so that goes like that. Okie dokie. This is a nightmare. Why would I do this? Right, let's see if we can assemble this. So that screw's going in here. Should have another short one. That goes in here. It's going in here. Oh no, please. Ah, I know what this is. You've got to be careful when you do assembly like this, because the pressure of the gear teeth is important. You've got to be really careful not to force them together, and they were forced there. I'm going to add a bit more lubricant to these, just to make sure that they're nicely lubricated. It'd be nice to have access to... Okay. So we do have to tighten it down, but that's not too bad. So that looks about right like that. This is where they might have a jig tool or something to help them align these gears and get everything set nicely, but I don't have such a thing, so we just have to make do. Try not to get too much grease all over the place. That can go in afterwards, I think. This can probably go on here now. So that just fits on the top like that. This goes through here, so this will need a screw. Nope. That goes the other way. Okay, so that's going to hold it onto the body by the looks of it, so we don't need that one just yet. This one we can put in here. That one's going that way, that one's going that way, that one's going this way. Once my dad was out of the house, I made myself a copy of his key out of aluminium extrusion just for the fire. Took me an hour, but he had the only PC in the house. Oh dear. That's quite funny though. So this screw has a nylock on the back, so here, because this is a moving latch, you don't want to tighten it down, so you need something that has what you call torque prevailing, so it maintains the torque that's been applied in some regard, stops it coming loose basically, and that does that job. So then you put the spring in here, and then you've got a spring latch idler. I didn't show the idler, but it's just a smooth bearing, it's nothing special. There's no twin drive thing like there is on the Mark III. So there we go, there's 2 screws and that's ready to go. Oh, please go through, there we go. 2, what was this screw for? Oh dear, have we forgotten? This is a... I knew this would happen. You know what's going to happen? We're going to assemble the whole thing and there's going to be a screw left over. Even after I was bragging about it as well. What a fool. Well, let's just hope we don't really need that screw because I don't know where it goes. So let's take a look at this little assembly as well now. I think this one is a little bit easier. I think it's fewer parts, so hopefully less opportunity to screw up. So these first 2 screws looks like the method for holding in the bearings. So you've got big LM10 UU, LM10 UU, yeah. So they're the long version, they're like double length bearings. Normally they're LM10 LUU for the long style, but the text that's written on them says LM10 UU. Maybe that LM10L is just a notation they use on the Chinese ones, whereas maybe proper ones they don't use that. Oh, leftover screw, yeah. Well, hopefully we'll find it. It might be that it's part of the other assembly, or I've put a screw in with a long one that should have been a short one. None of these look longer than they need to be. It looks like it should go in here, but I can't imagine how that's going to work. Oh, but that's going to be way too long. Oh, maybe that was... Oh, what have I done? No, this screw holds the filament sensor in, which I don't think I ever put in, so that's just not there, I think. But that would be covered by this, so how are you supposed to do that? I don't think that screw was ever in there. I think that one did not exist. Did I miss a screw? Let's have a look. It's bugging me now. I was just going to be all chill about it and be like, oh yeah, it'll be fine, but I mean, it probably would be fine. It's nice to get it right, isn't it? Oh, going to do this one too. I think it might be a third screw for the motor. That's why. Nope. Oh dear. We'll just have to pretend it's going to be fine. Maybe I'll find somewhere for it to go later on. It might have been a screw from an earlier assembly that I just didn't place in the right place on my desk. Entirely possible. So in this assembly we've got these two large bearings which we shall remove, and I think we shall go for a little bit of added lubricant. They will have moved significantly shorter distance than the other bearings, but going to get a bit of lubricant in there while it's all disassembled anyway. I'm going to lie them down because otherwise it's all going to pour out the end. I need to stop for a quick drink. Nobody ever colour codes screws as far as I know. It's just, there'd be more of a pain in the arse to colour code the screws. It costs so much. I don't think it would be viable. That's the right word, I think. I'm just a little bit concerned about how easy it's going to be to get this belt back on, because this is not coming off super easy. I think what I might need to do is start this assembly here. So the problem is with this assembly, I mean, it's not like a problem, but the problem I'm having because I'm disassembling it, I suppose you could say, is that I don't know what the correct order of operations is, so I just have to kind of take a guess and see if it works, and sometimes it doesn't. So what I do need to do is actually work on this carriage a little bit, because this is what's going to help me get that part off. I think I need to remove the belt, so I need to find a way to get that off. I think this should be one, and maybe a second screw to hold this in. But I've no idea where that second screw is. Oh. You were joking. I never know. I always try to be polite to people's comments just in case they are serious. Well, that doesn't come out. So where the dickens is that held in? Eh? This is getting confusing. Super duper confusing. I don't even just just don't know how. I'm going to take this pinder off, I think. It's just going to do that. That's not going to help. That's the fan. I don't think taking the thermistor and stuff out is going to help either. That's not going to help. Does this just... Oh, there we go. There we go. Oh my lord. Well, that's not the prettiest part, is it? Blimey. That's probably the worst quality Prusa Research parts I've ever seen, actually. It's in a place that's totally hidden, so it doesn't really matter what it looks like. It's been functional and works. There we go, so that's that assembly come off of there. Now we can get access to the belt, which means we can take this off of... Don't know which one we want to take off. Probably this one, actually. So you've got this carriage, it's just one bearing top and one bottom. That allows you to take... Oh, lost that, that's gone. Oh, no, was it? The roly-poly bearing has roly-polied away. I think this might actually... Could this screw be for this? Yes, I think that's for that, so that I'm going to put in there. I think that's for that, and I just happened to take it off while I was doing that part of that assembly. Maybe, potentially, possibly, hopefully. Yes, what was I saying? Yes, you can take the belt out once you take this carriage out through here. Why am I saying it like it's instruction? I'm not. I don't instruct you to do this. This is not a recommended thing to do. Don't do it. This is for entertainment purposes only. That's also not going to be super easy to get off of there. That looks like... How on earth did they get... Oh, they must have pressed the bearings on from the end, I guess. Let's see if we can take this off the end here. Oh, there we go. Give this a quick wipe. Bit of dirt on there. Then we've got the carriage, so just trying to... Okay. Excuse me. So yeah, this is, I mean, I feel kind of guilty showing this. It's really unnecessary to show, but who cares? I can do what I like. This is the inside part that I'm saying looks pretty bad. It's one of the worst parts I've seen printed by them. But again, it's totally not visible. Like, it just looks a bit crap on the inside. It's obviously printed face down. You can see the texture, so it's printed like that. And so it's just the bridging on the inside. But they've got this hole that's got a bridge across, which is not even possible to do. Hence, it's had some trouble. And it's been a bit of a gunky mess. This is the kind of thing that I would expect some maybe later designs to improve upon a little bit, perhaps. It's quite a complex little part. It's quite an achievement to get all this design detail in something that is so small. So they've done well. Just trying to get a little bit of the debris, dust and gunk out the end of the bearings. Again, going to stick a bit of lubricant in those before that goes back together. That's the belt, that's going to stay with that. Then you've got the rest of this assembly. I think we loosened these already, so I don't know why these rods aren't coming out. Oh, those are tight. I'm pretty sure this is totally loose. Yup. I can't even pull those out. I think that's a good enough reason to leave them in. Oh, that one comes out easily. This one does not come out easily. Oh well, that is what it is. So can we take this apart? Yeah, we can take this apart. The chat seemed to have quietened down a bit now. Do we have someone that was particularly noisy decide to leave? So, X-axis motor, standard kind of 4-pin, nice locking connector as always. This again looks like 16 teeth. Not sure if I want to count it. It looks like quite a bit of belt wear on this. Where should we count from? 1, 2. Hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 teeth. Cool. Yep. X-axis. Simple. The rods, as I mentioned before, already measured those. These are 8mm. Can double check what the length is. As always, measurements with a ruler, a tape measure are not going to be super accurate. 278. It seems like everything's 278mm long, doesn't it? I mean, you'd be quite smart if it is, because it makes... I'm never going to be able to get that back in. So this is the final part. This clamps the motors, clamps the bearings rather, and holds the motor on the back face there. Right. So that's that. I do want to try and take apart this Hotend a little bit. So let's do that. Let's make more mess. Look at the desk. It's an absolute mess. There's just stuff strewn across it everywhere now. As far as the eye can see. Let's take a quick picture. Cool. Right, let's have a little look at this Hotend. Hopefully we can. It's not going to be too much of a pain. So we got this little fan on the front. Be interesting to know if it's noctua. I'm guessing probably not, but the geometry looks remarkably similar. Maybe there'll be a little sticker on the back to help us know. Ooh, the whole thing just kind of disintegrates. It's not a noctua fan. It's a standard brushless DC fan. Well, the noctuas are brushless DC fans as well, but this, I believe, does have a new revision, which I didn't print. I think they released that actually very early on, soon after I got my printer. Wasn't planning to particularly clean it at this point, but there's quite a lot of dust on the Hotend, which is something you can't really avoid, to be honest, because whilst you're blowing air, unless you're in like a clean room, that air is going to have dust in it. So you're blowing air over components, they will get dusty. Nothing your printer design can really do to, I suppose you can add in filters and all that kind of stuff, but it's probably a bit over the top for a printer of this price. There you go, that heatsink's looking nice and clean again. I'm not sure that will really affect performance all that much. It wasn't a lot of dirt, just a little bit. So let's see if we can get this out as well. thanks very much for joining us. Hope you enjoyed it. Great to have you here. Hoping these, oh no, here we go. Maybe we can do it a little bit more. Tray, interesting. Oh, that's really in there tight. That's really in there tight as well. That PTFE tube is not really coming out. Gonna need some, this looks like Arctic silver rather than just standard thermal paste. It's quite a premium one if I remember. So there's a PTFE tube down in here. It's just held in the middle here by just friction, I think. I don't seem to be able to, I can't see anything that would be holding it in. These grub screws are not holding that in. So I don't know how that's being held in, but it is. So the two areas here, so you see this kind of curvature that fits my finger here and here. This goes straight up against the bearing, so it keeps the hot end very close to the axis, and it's all a very lightweight aluminium heatsink structure. This is quite a big heatsink actually, which helps them with printing high temperatures with a less expensive, fairly simple hot end design. This extrusion, you might think this is a particularly expensive part, but I would guess, given the shape, that it's not too bad. So how this is probably made, I would guess, I mean, I might be wrong actually, but I could be wrong. But my guess would be that this shape that you see in this profile has been extruded. So they'll have paid a reasonable sum, quite a lot, they can be quite expensive, an extruded mold that will just make this shape in a really, really long kind of sausage shape. And then it gets sliced up into things that wide, and then a couple of further machining operations to drill through the top to get these threads, these things in the back, and these grub screws. That would be my guess, but I'm not an expert machinist or in other manufacturing, so I might be wrong, but that would be my first guess as how it's made. It's really oh, here we go. Oh, this might be threaded in. It might just be, yeah, I've got this thermal paste stuff all over my hands now. Oh, and this is going to be important which way around this goes. I think that was in that way around. Please be that way around. So yeah, that's a piece of PTFE. So my interest was in how far down that PTFE goes. It's not particularly obvious, I must say. Because, is it PTFE lined? Is it technically a PTFE lined hot end? Or is that's not a good idea. Oh, this will help maybe. So that's going down 25 millimeters. So yeah, that's actually not going all the way down. So this is how they're managing to achieve the 260 odd Celsius that they can do on this hot end. Because it looks, if you've seen things like E3D's design and others, when you get a really large section here, it means you can have a lot of heat transfer up into the heatsink, which is not very good. But I think this wall is actually quite thin, and they do have a really big heatsink, so it allows them to dissipate more thermal energy up here, which means this is not as critical. But the problem with things like this is you typically will see a PTFE liner that goes all the way down to the nozzle. The problem with that is that the PTFE has a temperature limit of around 235 to 40-ish degrees Celsius. Once you hit that, it starts to kind of burn up and release fumes, which is not very good. So what you have instead is PTFE that goes quite a long way down, about that far, about to the top of the thread, which means you get PTFE a lot of the way, well, fairly close to the nozzle and block, but not too close, meaning you can still get nice high temperatures on the block without impacting the PTFE slightly further up. Quite an interesting Hotend design. It's clearly very similar in design to the E3D one, but I don't believe it was E3D that provided them this. I think this is their own, I say their own design. I mean, it's kind of the E3D design, but slightly modified, but there you go. Call it what you will, it's a Hotend. This actually looks the same both ends, so I'm not too worried now. That pressure's in there, hopefully about that far. Now I'm going to need some thermal paste, so I'm going to go grab that. I've lost my thermal. No, I haven't. I don't think we need diamond thermal paste. This stuff will do. It's a little out of date, so it might not be perfect. I don't think it lasts forever, but I think it'd be okay. Well, actually, before we do that, I think we should make a point about the fact that this is now totally disassembled. Like, this is it. This is the... This is peak disassembly. Look at that mess. Oh dear, if you thought it wasn't that bad, man. Oh, you can probably see worse from top down, actually. That's how you make a mess in just under 2 hours. Over 2 hours? 2.5 hours, blimey, okay. So I think it's probably time to reassemble now. I'm hoping we can do this in half an hour. But that does seem optimistic, doesn't it? Especially as the chance for failure is extremely high. As I mentioned, for anyone that wasn't here before, I have absolutely no guide. Right, this is totally winging it from beginning to end. Bit of winging it, bit of memory, bit of experience, and that's all I have. Hopefully, we'll get there. So, I think the first step for reassembly of this Hotend will be to get some thermal paste on here and get it back in the heatsink. I'm not sure how well this is going to go. It does fit quite tight, so I don't think I need a lot of this stuff. Any more than I need will just gloop at the bottom. I'm thinking that will probably be enough because I don't think it needs much at all. Well, that tube comes up further than I remember. There's a couple of fits on the top. It did. Maybe it goes the other way up. Yep. So get that on reasonably tight. Now I can't remember the exact orientation of this. I think it was probably that way, was it? No, that must have gone that way. Right, so I think that was on there, that was on there, that was all jammed in there like that. That looks about right, so let's take do this from here. I'm not sure if that's pushed all the way in actually. going to have to be because I can't get it any further. So let's hope that's fine as it is. Let's go back to a bit closer up, shall we? If we can. Oh, wrong mouse. Firstly, hello, and I'm pulling it to pieces and then putting it all back together. Because I can attempt to if I'd like to. I can't say because I can, because I may fail still. But I don't know, I just wanted to take it apart, put it back together. It's kind of fun to do it, and I thought it'd be kind of interesting to take a look at some of the parts and maybe talk through some of the design. Obviously, I can't explain their justifications for doing things and why certain things are certain ways, but I can make a guess, and hopefully a mildly educated one at that. I'm going to need a bunch of zip ties. Not too many, hopefully, but a few. I think it's a new bag of zip ties today. What a treat, eh? Probably best to make the assembly a complete 3-part stream. I'm not that fussy. I do like to complain a lot, I know, and I'm trying to be less complainy, but I reckon we can manage this reasonably quickly. I'm kind of hoping, because if this takes like hours, this is not going to be ideal. So don't need to tighten this yet, but gets the wires kind of in the right place. We can sort out specifics when we get a little bit closer to having an actual hot end. Oh, jeez. How the dickens are we supposed to assemble this? Oh, what way round does this go? This is the bottom. This goes one of two ways. Probably that way, so I reckon like that. Somehow we've got a belt in there and back out. So that's the bottom, this is the front, belt goes out that side. Presumably they're going to have done a modification to this part, because the belt, there's definitely belt wear on the edge of that part. I might take a quick picture of that. It might be useful for someone to see if they've not picked that up in their design process. Probably have, but in fact I'd be amazed if they haven't. I'm sure they've used this a whole lot more than I have. That's good to know. Have you found the V6 to improve your printing performance, or has it been much the same, just better quality hot end? I'm not sure what the maximum flow rate is of the V6 compared to the Creality hot end. Is everything visible? Not very. Do my best, but I'm in maximum memory mode, so I'm trying to concentrate. For anyone wondering, no, this is not a process I recommend. I think I've mentioned that more than once now, but I just want to be absolutely clear. It's not something you need to or should do. There's not a problem that you need to fix. It's just I wanted to try doing it because I thought it would be fun and entertaining. No clogs. The main reason for upgrading was temperature. I wanted to print PTG without having to worry about the PTFE releasing fumes. Yeah, I'm the same. The Ender 3 is cool. I do like it, but its lack of PETG capability is a... I wouldn't say it's a letdown. I mean, it's a very good value machine, but it's very much a nice to have, and that's good. Did you design printed files and stuff for that, or did you download some from online? Not hating either way, but just interested. So the real risk of doing this reassembly is just getting stuff like upside down, back to front, and not realizing, because a lot of the parts look symmetrical until you see the very small design details, and then you realize, oh shit, that needs to go this specific way. Like this cable on this motor, hopefully this is going to be fine like that, but it's really a bit of a guess. This hot end should fit in over here. And we know where the two screws are now, so that shouldn't take too long. That should fit in nice and easily. Although those are in the way apparently. Not sure how that fitted before. Did that come... Oh, maybe... Did they come up the back? Is that closer? That's not closer. Oh dear. Don't know where the cables were for the hot end. I don't know if they were... Was this at a weird angle? No, it can't have been. I think that must go that end and they went this side. I designed an adapter part and milled it together with my uncle on a non-CNC milling machine. Such a nice part. Also I printed cable mounts and a mount for the cooling part. Yeah, sure, send me something on Instagram, that'd be cool to see. Good job for getting all technical with the whole milling and everything. I used to use a mill back when I was at school. It was a very old machine, I don't know what it was, but it was good fun to do. I did enjoy it. It's weird because, like, being an engineer now, it's like, it's all just, well, not all theory, but you don't get to get very hands-on as a design engineer. So that's in place, but it's not fixed yet. This hot end also needs to be... These cables don't look right. I can't remember what they looked like though. No. I think a bit more slack like that, and that should be okay. As long as they're not really tight, that should be okay. One other issue that I can have, that grub screw's just stripped somehow. I don't have any torque ratings for anything. That grub screw's going to be a total pain if I ever need to remove that. Hopefully not. Because I don't have specific torque values for how tight things need to be, it's again a bit of a guess. You can do it as tight as you think it goes, but maybe it should be tighter or should be less tight. Without knowing, you don't know, if you see what I mean. These the same length? Yes. Oh, if you do send me a picture on Instagram, by the way, I'm not going to check it now. Sorry, but I will 100%. I'll check it afterwards. This fan is really tight in the back here. This must have only just fitted when they put it together because it's... Oh no, I speak wrongly. Cool, that's in nice and tight. Cool. That's the hot end basically done. That could be tighter and snugger, but unless I've been totally stupid, that's that lot in. Right, I think we can get these bearings back on here as well. These have some nice ridges / slots to keep them in place. This is there. I'll be so chuffed if this all goes back together without any hitches. Not too sure how tight this is supposed to go either, actually. Speaking of tightness, I think that's too tight because it looks like it's bending. Yeah, this is where like torque values can be important to get the tightness just right, and I just don't have that information, unfortunately. Hopefully my eyeballing it to be just about right will be just about right. Well, ain't that looking fantastic? I forgot to oil those bearings, didn't I? Right, we're going to have to do it the dodgy way from the end because Yeah, I'm not sure that's really done anything. As I mentioned at the beginning, they're sealed bearings. They're designed to be sealed. Adding oil on the outside does sweet FA. Okay, so that's probably a bit tight, to be honest, but I'm not sure what we can do about that. It does work, that's good. So, what are we going to assemble next? We don't need anything over there, that's good. So, next we go this assembly, I think. So we've got this part. Wow, this was a while ago that I took this apart, wasn't it? Come on, memory. Where are we going? I think something like this. And then something like this. A little bit of this and a little bit of that. Oops, a daisy. Throwing it all over the place. That's weird. Why does that screw not go straight in? You'd have thought once it's been in, it'd be easy to put in again. I'm going to risk it for a biscuit and drill this hole out a little bit more. Just to 3mm. I'm not going to go 3.5 or anything too large. We'll keep it as small as we can. Oh, you're building a Hevo. Nice. Very, very nice. Sounds good. There we go. That's fitting nice and easy in there. And that's nice and easy in there. Much better. So I think it's going to be easier for me to put this little thing in here right now. And there were 2 screws that held it together, probably these 2. This is the kind of part that's going to be useful to have a little bit loose now. And then we'll tighten it up later on. Probably forget and then go, oh, the print quality is rubbish, and then realise that I forgot to tighten something. It's normally the way it goes. So once we've got that in there, we can probably get this on here too, so that goes this way around. Label was right at the bottom and this is the top, so that goes that way. And there's 2 M5 screws in the end. This is reasonably square. Make sure that's nice and tight. So now I'm going to put these rods in. Tighten those 2 down. Ooh. Nice squeak on those, which is unexpected because they are going into proper threads, but there you go. So now I think we can chuck this onto here, like so. Come on, come on, come on. Yep, yep, nice. And then twizzle this bearing thing quite a lot until that comes down. Right, let's stick that in the right place. It does feel, based on what I'm doing at the moment, that they probably assemble it actually quite similar to this. Feels like the right thing to do. Not like morally. Yep, that looks like it would go like that. That's the rear, that's the extruder, so that's the right way round. That's going to go on here. No, yes, no, yes, no. Yep, like that. No, something's not right here. Sorry, you can't see much, can you? Wide angle's probably fairly good now. We're getting towards having a full printer sort of size, so. Ooh, starting to look like Mini again. Right, let's see if we can do this cable management properly. Cable management. I think this might have got a little bit twisted in the process, although that could work. These cable duct things are only just large enough for these cables. It's quite difficult to get stuff into them. But then again, it was only designed to be done once, and this is the second time, so. That looks good though. Where's my zip ties? Let's replace these. Zip tied in exactly the same location. Because it's made some light marks on the actual like conduit sleeve stuff, it's quite easy to tell where everything's meant to go, which is good. Okie dokie. That's looking pretty good. So we've got some cable management to do up this vertical edge now. So these cables come down here. Then we've got these ducting pieces, which fortunately are both the same length by the looks of it, so that'll help. These just squeeze in nicely here, tidy that up a little bit. Then that one continues all the way down to the bottom, and this other one joins in here. This cover goes over the top like so. And that gives you two wires that just come out right at the base. So it looks like I was just about correct with the orientation of this cable. That looks like it'll work like that, so that's good. This is starting to look like a Prusa Mini. Right, we've got some cables, screws rather, to stick in the base to hold this together. I couldn't tell you exactly why different people use different end stops. I'm sure there's a reason. It could be just stock, location, availability, pricing of various components. There's probably countless reasons why you could use different things. Sometimes it's just knowledge, or maybe they have a method to integrate something, or they got a deal on a board with a bundle and yeah, there's all sorts of weird reasons really. I've just noticed there's also a little Wi-Fi antenna. Well, I don't know if it's for Wi-Fi, but there's a little antenna plug on here as well. So presumably you could use that as the signal boost for the Wi-Fi. Holy moly, I think we're nearly there. Yeah, I think that's not too tight, so that's probably good as it is. Whoop! And get this filament sensor, jam that in there. Boom. This comes down to here. Right. This switch we need to get in here. I think we might leave that a little bit later actually, so it can help those other wires. That goes in last, that goes in last. LCD cable. Damn it, which way around does this go? I reckon that goes this way around. Now, did I put the nuts in the right place? That's the question. I mean, when I built this printer the very first time, this bit took me like 40 minutes on its own, so let's see if we can get any improvement in time there, because that would be nice. Is this I can't remember the length screw that we need. Let's give it a test. That's correct. Damn it! I don't know why I find this bit so difficult. I wonder if this part had a slightly newer revision. Ah, man, no. Oh, no, oh well. I think my depth perception is just effed when I look at it from the end. No, I really struggle with this, don't I? Clearly. I regret taking it apart. Just can't get it to bite on that nut. It's exactly the same problem I had the first time I assembled it, if I remember correctly. We made it, it's in. I remember this delightful issue too. On my revision, the alignment for the T-slot nuts is not right. So it doesn't quite fit. You have to pressure this. Let's try this. So Let me get that to there. I know you can't really see a lot, sorry. Nope, that's not right. I'm going to damage something if I keep letting it sit on stuff like that. There we go. So that goes there, that goes there. We need to loosen this one a bit. This whole assembly slides backwards to there. Move the bed forwards, and then we've got this screw here, which takes the very last one. Well, not the very last screw, there's still a couple to do, but we're getting there. So the last of that trio of difficult T-slot nut screws. Oh, that seems to have come out again. Obviously didn't do that quite tight enough. Oh, it's not being tightened. It's not tightening. Oh man. I had this. Victory was within reach. Right, that's in, so let's get them tight on a reasonably flat surface. Have you tried the F-nut? Yeah, I tried it before I did my mini review thing. I mean, it doesn't really do anything, so... They're like, their interface, all you can look at the moment is like temperature and stuff. It's like it doesn't really have much of a useful function at the moment. They're still working on the software, firmware side of that. Right, so we've got everything close to what we need now. I just need to remember, so let's double check now. Order of the cables. This is why you take photos. So now I've got this photo of the back of the main board. So it actually goes in a really odd order. So it goes Z, X, Y, E. Normally it goes X, Y, Z, E. This is Z, X, Y, E. E being extruder. So Z goes here. Come on, click into place, please. Oh, it didn't really click, but it's in. That's Z, and then X. And then Y, which is this extra, the one from here. And then we've got Z, which comes down off of, not here, hang on. Z, X, Y, E. E is the one that comes off of here, of course it is. We've also got the heater. Oh, this all looks a bit twisted, doesn't it? This is not very good. This needs to go like this way round, so. And that's pinder, that goes up there. Let's put that under that cable. Stick that over here. Pinder, and then what was next? Wonderful, thanks for sticking around. I think we're nearly done now. It's a shame you're not going to be able to catch the end. Then it's filament sensor. Hang on. Yep. Then it's this one, which I think is fan. Then I think it's this one, which is the other fan. This is the extruder. Yep, that one goes in here. And we've got the bed one, which goes in here and in here. Then we've got this weird bundle of cables. Oh, we have to put the power switch in, otherwise it's not going to work very well, is it? So we've got 2 screws left now, we're basically there, I think. Oh, I always forget which weird order these are supposed to go in here. It's some bizarre arrangement, isn't it? I remember that. I mean, in theory, I can get help on this bit because it's a standard part of the assembly. I think it's something like that. So the last thing is just to get the display on the front. Then we can plug it in, I think, and do a self-test and see how everything works. Or doesn't, which could just as well be the case. I think we might be pushing our time a bit for a benchy, I'm afraid. See what files are already on there. Oh, this is stupid. How there's not loads of people with damaged ribbon cables, I have no idea, because right. Made a bit of greasy mess on the bed, but hopefully it's avoided the print surface, so it should be okay. producing a peculiar sound for some reason. Not too sure why. I think the screen flickered then when I plugged that in, but hopefully it's okay. Okay, we're nearly there, nearly there. Let's just move this here and sort the camera. Right. Time to power it on and see if we get a success. Was that on? Oh, this cable's all a bit weird and funny now, but seems a reasonable start. Of course, all the recalibration stuff will have to be done, so we'll go to calibration, wizard, welcome, yes. I hope you can see that. Status bar is at the bottom of the screen. It contains information about those things. Press next to run the self-test, which checks for potential issues related to the assembly. We're looking reasonably okay. The filament sensor cable is all sort of in the way, but that's not the biggest issue. Hopefully the pincher triggers, otherwise we're in trouble. Oh shit. What the hell happened there? That's what we're going to call an epic failure. That was some serious bending. Did you see how much that bent? Holy smokes. Sorry. If I'd had a better angle, you could have seen that too. I'm not sure. It might just be in the height. So let's just see if we can pull the height of the printer down a little bit. I'm not sure what the height's supposed to be. There was probably... Oh, that probably says to do that weird thing that they say to do, isn't it? With, oh, shit. Not like that. The zip tie thing that they do. Let's do that. Yeah, I think everyone has the right to laugh. That was quite funny. Pinter's triggering now. It's just because I assembled it at an arbitrary height. I think it was just the wrong arbitrary height. but it was an arbitrary height that happened to be arbitrarily incorrect. And a calibration, and a wizard, and a yes, and the next, and the next. Let's give this another go. I think people are starting to tune out already now, so I don't think we'll bother with the print. I think everyone's realised that I've managed to assemble it. Satisfied that we achieved what we had set out to do. Please, 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 please. Yep. Boom. That cable is right at its very limit. Damn. Okay. It's actually easier for me to look at the monitor that's recording this than actually here. I know you really want to bench it, Tristan, but it is now 10:30. And I'm mildly exhausted. Ugh. We'll see. See if we can slice a quick benchy. Go on then, let's do it. Benchy or it didn't happen. As we've got profiles, I guess there's no excuse. Let's get some PLA out. Where's my, here it is. Seems we have a bit of a theme going with printing with this green on filament, on stream. Let's do that today as well. We're going to need to do some calibration as well. So it's going to need to go through there. All successfully finished. Just looking for me blooming benchy. There we go. Change to Prusa Mini. We'll do the fast one. Middle of the bed. Slice. Hour and 16 minutes. No thank you. Let's shrink it down a bit. 30 minutes. I think we're going to be a bit short there because I didn't push it in straight away. This Hotend is absolutely disgusting as well. I should. Right, colour is correct. Calibrate the distance. Next. Do you want to use the current value? No. Next. Yeah, I think the current value from before would be so far off that I don't think it'd be worth using. That was not electrical, by the way. That was just me hitting the edge of the screw, forgetting it was there. It's not a problem. This is the first, my one and only Prusa Mini. Well, this is not, so today's build is not a new Prusa Mini. This is the same first one that I had back in late last year. I'm not sure it's done the levelling quite right. Did it do a mesh level first? It did, didn't it? Yeah, it's not very even from side to side, but... I know you want to see me suffer. That's half the fun of these, right? I think we're getting there. It's only going to be half an hour, the benchy, and I might disappear for a part of that. Viewing figures normally go up when I'm printing stuff anyway, because, I don't know, people just want to see things printing. Oh, I've forgotten to mention for quite a long time, don't forget to like the video, like the stream if you're enjoying it. If you've been watching the whole thing so far, you really ought to have liked. I mean, up to you, but... do you want to repeat? No. Calibration successful. Let's just do a quick mesh bed level, because I think that could do with some improvement. Do 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 do. Can you hear this printer on the microphone? Like, for people that have been watching previous streams where I've done like the Ender 3, that ET4, the FL Sun, that Q5, like noise level wise, are they how do they compare over the stream microphone? Right, let's stick a doobly in. There it is. Using this printer from a weird angle is weird. That looks like it's in. Print. Time to do a bit of tidy up. free to sell. It's not free to produce. It's probably quite time consuming to produce. I don't mean produce as in like copy it. Produce as in make it work and get it right. But yeah, I know what you mean. I guess it's part of a Marlin firmware or something, is it? Must be if it's on the Prusa. It's all open source, right? So it's all there. Probably leave that out for a little bit actually. Go away. First layer's a bit close. It'll be alright. If anyone has questions and stuff, now's probably a really good time to ask. Just going to be waiting for this print, and then that will be the end. It's going to be 20 minutes or so, so it's no rush, but that's what we're doing. Yeah, my viewership's gone up just because we started printing something. Wow. Can't believe we actually managed to do it. Oh, basically the entire printer totally to pieces and back into a functional printer in what was it, 7, 8, 9, 10, nearly 11. So, wow, 4 hours. From 7 o'clock to 8 to 9 to 10 to 11. Why does it not sound like it should be right? Yeah, that's right. Yeah, no wonder I'm mildly exhausted. Nearly 4 hours, blimey. What time is it there? It's this time here. You're welcome, Microtech. I'm glad you've enjoyed it. I think it's quite good to do. I mean, hopefully it provides some value to people that... I mean, it does seem like when you buy a kit that's pre-assembled, it gives an opportunity to like hide things, and hopefully this kind of has demonstrated that that's not really the case with this printer. Like, okay, I think the one thing that we found that was not particularly amazing, well, one thing I didn't particularly like, with that print quality in the back of that fan duct, but I mean, who really cares? Like, it's not, the prints are good, right? Like, that's what matters. Can we get the focus to go over here instead, please? It's now, I don't need to see the screen now, I need to see the print. There we go. I'm back. Welcome back, Snell. What's your opinion on overall performance of the Mini versus the Mark III? Apart from print volume, do you think it's a valid contender? Yeah, for print quality, they're super similar. They really are. Like, Prusa would not have sent this printer out as a finished product if it didn't have similar print quality, because part of that brand is to provide very easy to achieve, very good prints. They may be not absolutely perfect. Like, you can, if you tune for hours and hours and hours, you can probably improve them. Like, sure. But for totally like out the box performance, it's pretty unbeatable, really, isn't it? I think I might have over tightened the screw here. It looks like it's jamming that part a little bit. Let's probably undo that a little bit. Looks like I got a bit keen with, holy shit, really keen with tightening. Yeah. What are the other performance things? Heat up time, I find largely irrelevant, to be honest, as a performance factor, especially when you don't have to watch it heat up and wait for it to do anything. You just go, I want that, please, and then you come back later. Like, that's fine. The performance, the usability, the user interface on this is so much better than the Mark III. Because it's, well, I don't know if it's entirely because it's 32-bit, but it seems to be because it's 32-bit. The processing of the really basic stuff like menu commands and USB drive stuff just means scrolling through the menu and you're not like juddering, or it's just so much better. The Mark III is what, like 3-4 lines you get. It's such a basic interface, and it really, now that we know we have stuff like this, that interface makes that printer a bit of a pain to use. I mean, it's not a pain to print, to be honest, because you barely use it. You like press it in, press a button. It's not much, but if you're trying to like move things manually and do other stuff in the menus, it does feel really, really archaic now. In terms of maximum print temperature, I know the Mark III can go a little bit hotter on the bed and on the nozzle, and for printing things like PC blend, which is a Prusa material, they do say you have to do this lower temperature. I think maximum bed temp on this is 100, which is still pretty warm, but for polycarbonate, their polycarbonate blend, I don't think it's really quite hot enough. I think they recommend 110 on the Mark III. So, but then it's smaller, so you're not going to be able to do such big parts, which won't have such serious warping either. So. Sorry for yawning. It's really hitting me now that I've finished the building process. Oh, we got a temperature readout as well from last week when it was really, really hot. Now it's only mildly warm, 25.9. I've still got the fan in here because it's still quite warm, but there's mainly just lighting now. Like, those lights just make the room really hot. I think this might come out as a slightly mushy print. The high-speed 0.25mm layer profile on a very skinny little bench is maybe not the best plan, but it will be quick, and that's what I wanted. Right, as there's not much happening in chat, I'm going to just go and wash my hands quick because they're still kind of oily and greasy. I'll leave this obviously for you to watch. I shall be back in just a couple of minutes. I have returned. How's it looking? Yes, as a very fat layer, very small benchy might be expected to look. A little bit splodgy. As I mentioned, if anyone has any questions about things, what we covered, I don't know what people would have questions about, but if you do have any questions, go for it now. Anything upcoming, previous videos or anything? Looks like we're nearly getting there now. 67% of the way through. Can't quite see time remaining. 10 minutes. Shouldn't take too long to do that. Well, 10 minutes. Looks like a lot of people are tuning out now anyway. So, of course, thank you very much to everyone that's been watching and enjoying the stream. Of course, don't forget to like it if you've enjoyed the stream. It does help me out a lot to indicate what people enjoy and what they don't. If you want to see more streams like this, I try to do one every single Sunday around the time that I started, so 7 o'clock BST at the moment. Normally we do the unboxing, first print, well, normally build and a first print on a printer. Gives a really good overview and a look at the kind of stuff that you would expect when having your first experience with that particular printer. Kind of stuff that comes in the box, as well as the build process, what works well, what doesn't. We also tend to look at all the kind of stuff that's inside, so look at the stepper drivers, the motor, the power supply, some of the wiring, to give you an idea of some of the safety things that sometimes can get missed by being hidden in a little enclosure that nobody tends to open. So yeah, those are the sorts of things that we normally do on a Sunday, and then videos normally on a Wednesday-ish. Well, hopefully 5 o'clock, but this week I forgot to schedule one, so it was a little bit late. But yes, every single Wednesday should be videos. That's normally 5 o'clock. I'm thinking of trying to make it maybe a little bit later, just try and hit that peak a little bit more, but generally that's when I do tend to upload Wednesdays, and then live streams on Sunday. This is the time here now, so that is why I'm feeling a little bit tired. I've just realised there's a big scratch along my desk from where I moved something, so that's not ideal, but that's fine. There's really such a small amount of printing to do. But I think it's going to have to start slowing down because it's doing quite thick layers and it needs to let them cool a bit. So I'm assuming nobody's asking any questions rather than chat being dead. I'm assuming chat is still fine. It's just everyone's just watching it and tuning out. That's right. It's not been stressful. It's not stressful, I just kind of want to sleep at some point and eat something because I'm pretty hungry as well. We've got a really nice surprise coming in the next couple of weeks as well, so that's going to be, well, it's not a surprise for one person, but will be quite an interesting build. Coming right up towards the top. I think hopefully this has proven that it does work though. Like that was the point of this print. After taking it completely to pieces. I would agree we didn't go like 100% completely to pieces, but I mean, it was just some of the odd screws, a couple of bearings we didn't push out, but I mean, we basically took it completely to pieces, as far as you could reasonably expect, and all the way back again, and the print, and the calibration. Boom. If this doesn't show you the entire process from parts to print on a Prusa Mini, I don't know what will. It's got to be the most thorough review on that process. If you slice a full-size bitch, you have time to cook some macaroni and cheese and get your chip chats. Yeah, I could have done, but I'm not going to do that. I did have a... I don't know if I should share the idea. No, I'm not going to do it. I'm sorry. I'm at that moment where I just get these random ideas that pop into my head. And then I'm like, oh no, I probably shouldn't say that. Because if it's a good idea, it might need to be discussed first before telling everyone what's not going to actually happen. I've run out of water. I've drunk this whole water as well. We've only got 4 minutes to save the world. Do you fancy a bit of mac and cheese now? Yeah, maybe you can help me with something while we're sitting here for the last couple of minutes. What's a better title for this stream than Disassembly and Teardown? I wonder if some people think of Teardown as like I'm getting rid of it rather than just... What's the right words for what we did today? Disassembly and reassembly? Just a reassembly? A closer look? Is it a detailed look? Is it a breakdown? Like, what's the right words? I feel like a couple of people came into the stream expecting me to be like, oh, it's all shit and this is rubbish, but it was not about that at all. It was about, let's take a closer look at all the little bits inside. Mini madness. It was madness. Trying to do a complete disassembly, reassembly and a print in one live stream is madness, I'll tell you that much. But we have achieved it. It's nothing quite like an achieving a goal, is there? 2 minutes to go. Basically there. Front of the roof, chimney to go. Is it going to be able to cool that chimney into something that's not going to be a big smudgy mess? It's okay at the moment. It's still going. And the wider bit at the top. And we're there, pretty much. No, still going. There we go. Did anyone else see that it went from 98% straight to 100? And then it was sleeping, and then 100%. I'm guessing that's the end G code after the end of print. Oh, well, there you go. Nice. That, ladies and gentlemen, is how you do that. Let's see if we can get a nice little close-up of this benchy. Pull apart a Prusa Mini and play with it. Prusa Mini with the outside and in. That sounds quite cool. This is mine. There are many like it, but this one is mine. But I might put Prusa Mini from the outside in. That's quite cool. Closer look, detailed look, disassembly, detailed look. It's so weird, isn't it? What are the right terms to use? So the benchy, I wouldn't say is perfect, but it's also the really silly, really thick layers on a very tiny benchy. This is a 60% size, so I don't really ever do them this size. Well, I do them all the time actually now, don't I, on live streams? But there and back again. I think I'll get a copyright strike if I call it there and back again. Oh, don't tell me now. You want you want another one in orange. You're getting this one. I do want to stop using the Prusa Mystic Green though. It's really difficult to look at on camera. There's a weird like band in here. It's not too bad at all for a quick slapdash print at the end. Right, that is the time now. 2300 hours. Oh, let's change. That is now definitely the end. Don't forget to like it if you enjoyed the stream. If you've watched the whole thing, then you should probably like it because it seems like you might have done. Also, you can subscribe down below, hit the bell to get notifications, and I think you have to turn it on and some other things as well. Just click and try and turn the bell on and all that kind of stuff. That'll give you a notification for when I go live next time and any uploaded videos that I do. So videos are Wednesdays, live streams like this on Sundays. Hopefully we'll do some more printers. It's quite nice doing these builds and unbuilds. Unbuild, maybe that's the right term. An unbuild, but nobody's going to Google that or search for that. Anyway, good night, everyone. Thank you very much for watching, and I will see you. What am I doing with my hands? I'll see you in the next one. Bye-bye for now. Oh dear, I don't know how to turn it off.